Okay, in this one they tell you Q1 and Q3 and they want you to find the mean. And so first thing, even though you don't necessarily have to, I think it helps a lot to draw a normal distribution so you can label the things you're looking for. So I know that the mean is right here in the middle. And I know that one standard deviation away, let's say it would be here, like that inflection point, and one standard deviation away in the other direction. Okay, so one thing to remember is when they tell you Q1 and Q3, that's not one standard deviation away, it's a portion of a standard deviation. It's not quite one whole standard deviation. So Q3 would be about here, and Q1 would be about here. And so I go, well, how much of a standard deviation away is that? Remember our magic number, 0.675. And so I can say, well, let's just do Q3, for example. Q3 is the mean plus 0.675 of a standard deviation. Okay, so what kind of stuff can we find out here before we even have to use the formula? Well, if I know the mean is right in the middle, and this is this one's 229, and this one is 391, I can figure out what's halfway in between both of those numbers. And halfway in between both those numbers will at least tell me the mean to start with. So I can find the distance between them. I could do 391 minus 229. You can add them up and divide by 2. A lot of stuff, whatever you want. Yeah, let's add them up and divide by 2 because we did the other one the other way. So 229 plus 391 gives you 620. And so divide by 2 is 310. And so our mean here is 310. It's not a bad idea once you get a mean also to check and make sure it's actually in the middle. So the mean is 310, and they don't have units on this one, right? Otherwise I'd make sure I write them. So 310, whatever the thing is we're talking about here, units. And then check and make sure if I go, okay, well this looks like it's 71 above this, or sorry, 81 above this, 71 to get up to 300, another 10. And then this one is 81 above that, so you can tell that they're kind of equidistant. Okay, so one thing to be careful about, the distance from here to here is 81. What we're looking for standard deviation is the distance from here all the way to here. Okay, so how can we figure that out? Well, we know if this distance from here to here is 81, that represents 0.675 of a standard deviation, not a full standard deviation. So if I know 81 is the same as 0.675 of a standard deviation, if I divide both sides by 0.675, we're just trying to get the standard deviation term by itself. So divide both sides by 0.675. And notice I'm only using part of the formula, but it's like I've already taken this part of it out. I said Q3 is 391 minus 310, so I already know the distance is 81. You can do that part ahead, or you can use the whole formula if you want to. But really I like this because it's getting at the meaning of what we're trying to do, is we know how far it is from here to here. We know that's 0.675 of a whole step. We want to know how big is the whole step. So 81 divided by 0.675 gives you 120. So there, you just found the standard deviation and the mean.